The graph of the relation y equals x squared plus 4 is below. Use the graph to find the domain and range using interval notation and determine if the graph represents a function. In order to find the domain and range of a graph, we're looking for, starting with the domain, what we're looking for is all of the values on the x, so along the x-axis, that have something defined in the y-axis. So for instance, at the point 1, we have something defined because there's a point on the graph located there. So 1 is part of the domain. So is -2. -2 has a point. It does go above the graph, but what's sort of understood here is unless we have a solid circle or an open circle that's telling us clearly that the graph is stopping there, the best thing that we can do is assume that it continues on to infinity. Now, technically, we should have these arrows here indicating that, but not all graphing technology provides those arrows, so just assume if it's not told to us explicitly that it stops, that it continues on. So what that means is this graph continues on, and therefore there is some point defined there. All right, which means we should be able to find a point for all values along the entire x-axis. Now, one way to think about that is if you were to take all the points on the graph and just smash them up against the x-axis, that should provide your domain. Let me show you what I mean there. So here's another graph of it, and what I'm going to do is I'm going to smash everything up on the graph against the x-axis. So let's see what that looks like. So I have these crushers here, and they're just smashing the function up against the x-axis. Now, if you'll notice, it only went to about 2.8 or something like that. But as we said, there should be arrows indicating that this graph continues on to infinity in both directions. So in fact, the domain of this function, this set that we're now looking at, is going to be all real numbers on the x-axis. Now, the range is a similar concept. The only difference is we would smash everything up against the y-axis. So if we were to imagine the same sort of situation where we're crushing everything up against the y-axis, the remaining points that exist, we end up with the range of the function. So the range begins here at +4, goes off to infinity. So our answers here, the domain, is all real numbers. So that's represented by the set from -infinity to +infinity. And the range began at 4 and included the 4 and goes to +infinity. Now the question is it a function? Well, a graph represents a function if it passes what's called the vertical line test. So the vertical line test is pretty straightforward. If there is a vertical line that you can draw that's going to touch more than one point of the graph at any particular place, and this only counts for a vertical line because that's why we call it the vertical line test, then it's not a function. If it touches at just one place everywhere, it is a function. So any vertical line that we were to draw here would only touch the graph at a single point. There's no way that we could draw a vertical line on this graph and have it touch the graph at more than one point. So therefore, it is a function. And you can really see here that a vertical line at any place would only touch the graph at a single point. So therefore, this passes the vertical line test, and that means the graph is a function.